can we talk a little about mechanistic stuff? Because I think it's like one thing, it's interesting to see a mechanism, but I feel like it's more interesting to find a mechanism after you've already found a pathway with something versus just speculating with a mechanism, which you maybe know the numbers. Like what are the odds of if some mechanism that we discover actually playing out in the human body the way that we think it will based on that mechanism?
Oh my gosh, less than 0.1%, I would say. And the reason for that is our body is super complex. So basically, a mechanism is looking at a biological pathway where you have different molecular partners, and you're saying, okay, well, this chemical binds to this receptor, which activates this protein, which then turns on this transcription factor, which then activates this gene, which makes this RNA, which makes this protein, and so on and so forth. And so mechanism is looking at kind of the inner workings of a biological process in the context of at the molecular level. But I think I think a lot of people don't realize that these are all kind of happening simultaneously. And a lot of these molecules that are signals or, participate in these signaling pathways, participate in multiple signaling pathways, and they can activate them, they can inhibit them, they might require a partner or a cofactor, they might be only turned on in certain cell types or tissue types or organ types or species. And so, you can't simply look at a mechanistic study, which are typically done in a petri dish with cells that are all identical to each other, and an animal model that's not a human, and say, okay, well, we blasted them with arachidonic acid artificially. We took some, in solution with none of the other molecular components and none of the physical food source, and we saw this impact, because that's not how it happens in an organism, and certainly not in a human, because digestion and metabolism and how all these different systems play with each other is so much more complex than that. And so, we humans, people, fall into the trap of exaggerating or mischaracterizing the findings of a mechanistic study or an in vivo study or an in vitro study, and certainly not just with nutrition, with a lot of topics. But, I think it's compounded by the fact that you have these bad actors online who use their credentials, and they legitimately weaponize their credentials. There's a PharmD, James DeNicola Antonio. He, I think he goes by something DeNick on social media. He's got millions of followers, and he published a paper he published a review that basically was demonizing seed oils, and he wrote about how harmful they are, and his Instagram posts are filled with, avoiding seed oils is what you should be doing for good health because it causes obesity and diabetes and heart disease. And he says, you shouldn't eat cereal grains, no seed oils. He obviously sells a lot of supplements. He owns a company called CardioTabs, which is a nutraceutical company. He wrote a book called The Salt Fix, and he has a whole bunch of conflicts of interest to kind of shift people away from consuming seed oils. But it gets really hard for the average person, because he, again, is exaggerating the mechanistic finding of a singular study, and is now demonizing this molecule that, if you give cells in a petri dish a mega dose of anything, you're probably going to do something harmful to them, whether it's something we consider beneficial or not. The same is true for causing cancer in vitro. You can give cells in a petri dish 8,000-fold dose of cinnamon, and you would cause cancer, in the mechanistic form, but that's not what happens in people.
Mm-hmm. Yeah. And when you look at the seed oil research we have, you find that the human outcome data suggests that they're benign or even protective in some cases. So then it's one of those things where you go down that rabbit hole, and you have this situation where you get a bunch of rat studies and mechanistic stuff thrown at you. But then you rebut with, but what about the human outcome data? The stuff we're actually concerned with, and then it's like there's probably some pushback in terms of like, again, like we were talking about before, oh, that was based on weak epidemiological studies and things like that, where it kind of takes us back to the original topic of like, what are we trying to measure and how accurate can these measurement tools be based on the context? And it seems like when you actually look at mechanistic studies and animal studies, the way that you described them, if you're going to argue that the human outcome data based on epidemiology is weak, you're probably going to also have to take the hit that your mechanistic speculation and your rat studies are also probably quite weak, if not much weaker. Do you have any thoughts about that?
Yeah, no, I mean, it's a great point. So, when you look at the hierarchy of evidence, your lowest on your pyramid is a case study. So that's a single entity or an expert opinion. So that's, one person saying, well, I think this, therefore it is true. So that's your lowest of the low. Then you have in vitro and animal studies, because again, they're not in humans. So, there are limitations to what you can conclude about those findings. They're useful to make informed hypotheses to then expand upon or use for subsequent in vitro or in vivo studies and ultimately human research. But they rank below even things like observational studies or case control studies or cohort studies, which are all essentially different types of human epidemiological studies, even human survey data. Obviously, the very, very top, your kind of gold standard is your randomized controlled trials. And there are some in the context of nutrition sciences. But of course, those, are very time consuming, sometimes prohibitive for people to participate in and things like that. So a lot of nutritional data is looking at these longitudinal studies based on epidemiological data. So they're looking at trends or patterns within populations over time, looking at health outcomes over time. You could look at things like life expectancy over time. But again, all of those data, even if you considered it weaker than a randomized controlled trial, is still more robust than an animal or an in vitro study.
Mm-hmm. Yeah. The other one I'll hear from time to time that I find sort of interesting when you actually dig into the details is the Minnesota Coronary Heart Study. So that one gets cited as some sort of human data that would suggest that seed oils are problematic. But if I'm not mistaken, and you probably know more about it than I do, but did that study just simply not really reach power and also have a situation where basically what they were looking to do with that study didn't actually happen, but there's some data floating around about it that it gets used sort of inappropriately?
Yeah, so let me just make sure I'm remembering. So that's the one that was done in like the 60s in the nursing home. Is that right?
Yeah. It was supposed to be 5 years, and I think
they replaced saturated fat with vegetable oils that had linoleic acid. Yeah. Okay. So basically, and that actually has been reanalyzed over the years. And so they they collected samples from, I'm actually just pulling it up really quickly. They looked at serum cholesterol levels over time for about 2,000 individuals. And they looked at the replacement of saturated fat with linoleic acid derived primarily from corn oil or corn oil margarine. So margarine is essentially like whipped vegetable oil. So it's solid at room temperature, but it's a vegetable fat. It's not butter. And the control diet was primarily animal fats and so on. And they looked at their main outcome was all-cause mortality. They looked at relationship between serum cholesterol levels, death, and they looked at atherosclerosis, so cardiovascular disease, as well as heart attacks, myocardial infarction. And what they said was basically the data weren't completely published, and they suggest that we saw a decrease in serum cholesterol, but they couldn't find a relationship between that and reduction of death, all-cause mortality. Now, of course, there's a lot of confounding variables here. We're looking at a very niche population. So you're looking at individuals who are hospitalized. So the majority of individuals were coming from mental institutions, inpatient mental institutions. You had nursing home patients. But there's a lot of essential flaws with how they were actually crunching the numbers, so to speak. And so they claim that the trials, they saw a reduction in the cholesterol levels with switching to vegetable oils, but they didn't see a reduction in mortality. Now, when you actually look at the data 50 years later, because we know a lot more about metabolism and so on, there's actual, demonstrable limitations and actually, gaps in what they could do. Not necessarily anything that they could have controlled at the time, but simply due to the nature of the subjects that they had to work with and their understanding of nutrition and metabolism at the time. So you actually look at, the findings in more detail is that, they're not looking at other pathways. They're not looking at other biomarkers. They're not looking at ratios of omega-3, omega-6. They're not looking at, how relevant the diet they fed them was to the American diet or just diet in general. So they basically created fake food to feed these people, which again is not relevant. So you have to also look at not just the findings. So you could say, okay, this is a randomized controlled trial, but it's not a relevant randomized controlled trial. And so it's really important to look at the study design when you're looking at the findings of a study, because the study design, if it's done poorly, that's going to skew the data you collect from it. And that's really the first point where bias can be introduced into a study. In addition, this was a very, very short duration because essentially they were utilizing patients in these mental institutions and they actually kind of shut down several of them. So like they lost 3/4 of the cohort that they were actually going to be looking at. And so again, they were missing a lot of information at the end. So, there have been a lot of studies since then, that have demonstrated that these seed oils are not harmful, often are benign, and in many cases can be protective. And it's unfortunate that people kind of cling to something that's 50 years old as evidence when it's essentially been debunked with better quality studies.
Thanks for tuning into this episode of the Human Performance Outliers podcast with Zach Bitter.